Welcome back to Fractions lesson number 3. This is a continuation of the Fractions series where we have already looked at how to turn improper fractions into mixed and vice versa. We have looked at how to multiply fractions together, divide fractions, all with mixed numbers, as well as simplifying fractions. Today we are going to expand this into adding and subtracting. So hopefully you managed to have a go at these starter questions. Looking at these starter questions, the first one's asking us to do 1 whole and 2/15 as an improper fraction. So change this mixed number into an improper fraction. So if we do this, remember we have to do the denominator times by the whole number and then add the numerator. And we looked at why this is last lesson. So we're going to times those two and add the top. So what does that mean? That means 15 times 1 is 15 plus 2 is 17 over, remember the original always stays as the denominator, so 17 over 15. Moving on to the top right question. This is asking us to multiply two fractions. When multiplying two fractions, they're the best ones, they're the easiest. You just times top by top and bottom by bottom. And what I've got here is two different methods of doing it, because last lesson we looked at how do we cross cancel. So if we look at the standard method where we would simply just times across, we've got 5/6 times by 2/4, which means we would do 5 times 2 is 10 and 6 times 4 is 24. Remember, we always need to try and simplify fractions. What number goes into 10 and what number goes into 24? The biggest number preferably, 2. 2 goes in 10 5 times, 2 goes into 24 12 times. So the answer to this question should have been 5 over 12. If we look at the cross-cancelling method, we discussed cross-cancelling method is very useful, particularly when the numbers get a little bit bigger. And how we do this method is we check the diagonals, and it only works when we times, remember, it only works when we times. We check the diagonals. We've got 6 and 2. Can you think of any factor of 6 and 2? 2. 2 goes into both of those. 2 goes into 2 once, and 2 goes into 6 twice. Not twice, 3 times, sorry. So we can say 2 goes into 6 3 times, 2 goes into 2 once. That is going to cancel it down. Essentially what we're doing here is we're simplifying early to make our life easier. Checking the other diagonal, 5 and 4, no. There isn't a common factor apart from 1, which is useless. So we can't cross-cancel those, but we can definitely do these. Once you have cross-cancelled, you can times across. So 5 times 1 is 5, 3 times 4 is 12. The answer to that is 5/12. So as you can see, same answer, both methods. Cross-cancelling can be very useful when dealing with bigger numbers. Moving on to the bottom left, exactly the same. We're going to do 3/7 times by 1/6 the standard way, just by timesing across, which would give you 3 over 7 times 6 is 42. You should always try and simplify. Now, this is a little bit tricky because the numbers are bigger. What goes into 3 and 42? Well, if you're unsure, because 3 goes into 3, but you might not know if it goes into 42. We know that 3 times 12 is 36. So 3 times 13 would be 39, and 3 times 14 would be 42. So in fact, 3 does go into 42 14 times. So we can simplify this to 3 goes into 3 once, 3 goes into 42 14 times. So that is 1 over 14. So this is where cross-cancelling can be your friend and can be very useful. If we look at the same question and explore cross-cancelling, let's check the diagonals. Remember, it only works when we times. Can you think of a number that goes into 7 and 1? Well, no, they're both prime and there is no common factor apart from 1. So we can't cross-cancel these, but we can cross-cancel these ones. What goes into 3 and 6? 3. 3 goes into 3 once. 3 goes into 6 twice. Now I can multiply across as normal with my new numbers. We got 1 times 1 is 1. 7 times 2 is 14. And as you can see, we get the same answer without that complicated having to work out if 3 goes into 42 step, because we simplified, cancelled early. Really, really useful skill to be able to do. Cross-cancelling. You can't do it all the time. You can only do it when you're multiplying, and sometimes it is impossible to do because there are no common factors in the diagonals. Looking at the next question, we can see that it is asking us to divide. So you must recall dividing fractions, KCF. We looked at this last lesson. Keep, change, flip, change. So we keep, change, flip. However, the next thing you should spot, these are mixed numbers. And we discussed last lesson, we always need to change mixed numbers into improper fractions before we start operating with them. So let's do that, and you should be confident at that now. 8 times 2 is 16, plus 2 is 18 over 8, divided by 4 times 2 is 8, plus 1 is 9 over 4. So we've changed them into improper fractions. Now we can do our KCF method, keep, change, flip. We're going to keep this, we're going to change this to a times, and we're going to flip this one. What does that give us? That gives us 18 because we're keeping it over 8, times by because we're changing it, 4 over 9 because we are flipping it. This is where cross-cancelling can be very useful. I don't really want to be timesing 18 by 4, and this is because these numbers are getting big. So I can check my diagonals. 18 and 9, does anything go into 18 and 9? Yes. 9 goes into 18 twice, and 9 goes into 9 once. Check my other diagonals, 4 and 8. Does any number go into 4 and 8? Preferably the biggest one. Yes, 4. 4 goes into 4 once, and 4 goes into 8 twice. So I've just taken what would be quite a big process of this question, where I'd times the numbers together and then see if I could simplify, into quite a simple 2 times 1 over 2 times 1. So that is going to give me 2 times 1 is 2 over 2 times 1 is 2, and 2 over 2 is simply 1. So the answer to that question is 1. Cross-cancelling, very, very useful there. Remembering our rules, change them into top-heavy first, and then KCF, keep, change, flip. So moving on to today's lesson, where we will be looking at adding and subtracting fractions. Something that students in year 11 every single year always just forget, and they decide to just do what they feel is right by, they just add across. They do what they do with multiplying, and they'll just say 2 add 1 is 3, 5 add 3 is 8. The answer is 3 over 8. That is completely wrong. It would be nice if it was that simple, but you cannot add fractions or subtract fractions when the denominator is different. So the first note that we should make here is you must have a common denominator. Okay, you have to. What does that mean? It means, it's a fancy way to say the bottom number needs to be the same before you can add them. So if I'm looking at this worked example, 5 and 3, they're not the same, so I can't just do what most students do when they forget and they just add across. You can't just do that. You have to make them the same. What are we going to make them? So exam skill would be, I always write out 2 blank fractions ready, because I know I'm going to have to change one, or both in this case, because they're not the same. So I can write out 2 fractions ready to be changed. 5 and 3. What number does 5 and 3 both go into? 15. We could make the bottoms 15. Now they're the same because 5 and 3 are factors of 15. A good method you can use to help you do this is to draw that shape on your fractions when adding or subtracting this and this. That helps us work out what needs to be times to make a common denominator. Or you can just think to yourself, what do they both go into? But a lot of students like this because how do I get the bottom number? I follow the lines. 5 times 3. 5 times 3 is 15. How do I get this one? I follow the lines. I do 3 times 2 is 6. And this all stems from whatever you do to the bottom of a fraction, you have to do to the top to keep it the same. So if I times 5 by 3 to get it into 15, I have to do the same to the top and times that by 3, and 3 times 2 is 6. So this method is just useful to help you get into a system of timesing it in the right direction. Or if you'd rather just think about it, that's absolutely fine. That's how I do it. 5 times 1 would be 5. Now the bottom numbers are the same. Most students always forget to change the tops. You have to make sure if you're changing the bottom, if you're messing around with the bottom, you do the same to the top. So now I can add them. And how do we do that? We simply just do 6 add 5 is 11 over 15. Okay. Always check to see if we can simplify. Always check if it's top heavy. Neither of these apply here, so we can move on. And hopefully you can pause the video and have a go at this one. First thing you should ask yourself, can I add these? No, there is not a common denominator. So I need to write out 2 blank fractions ready, and I need to make a common denominator. So you can either do this by thinking about what they both go into, or you can use the method discussed where you can times across to make the common denominator. So the common denominator is going to be 3 times 5 is 15. What goes here? Well, it's 2 times 5 is 10. What goes here is 1 times 3, which is 3. Or alternatively, think to yourself, what do I times 3 by to get 15? I times it by 5, so I have to times the top by 5, which is 10. What do I times 5 by to get 15? 3. So I times the top by 3, which would be 3. So same method gets you the same answer. Adding now, we'd get 13 over 15, because you're allowed to add. Once they're the same, you can add across. So that would be 13 over 15. Okay, so you can have the opportunity to have a go at these. Pause the video, have a go, and I'll talk through them. And you can check once you've done them. So here, can't add, need a common denominator. Common denominator is going to be 7 times 5 is 35. 35 on that one. What goes here? 1 times 5. What goes here? 2 times 7 is 14. Add them together, we're going to get 19 over 35. You always want to check if you can simplify. 19 is a prime number, so that is as simple as it will go. On the next one, same thing. We cannot add because they do not have the same denominator. So we're going to make it the same. We could do 5 times 7 is 35. And what goes here? 2 times 7 is 14. What goes here? 5 times 1 is 5. Adding those together, again, we get 19 over 35. And you might have spotted that these two things are the same. They are just the other way around. And when we add stuff, it's commutative. If you add 2, add 3, you get 5. If you do 3 plus 2, you also get 5. So no matter which order you do it in, you will get the same answer. Moving on to the next couple. Same thing. Can't add, don't have a common denominator. We're going to write out 2 blank fractions ready. We're going to decide what we're going to make our common denominator. In this case, we can do this method if you prefer. 5 and 7 is 35 again. What goes here? Well, 2 times 7, and that's 14. What goes here? 2 times 5 is 10. Adding those together will give us 24 over 35. Can we simplify? No, nothing goes into both of those. Next one, same thing. I don't have a common denominator. I'm going to write out 2 blank fractions ready. I'm going to decide what my common denominator is going to be, which would be 5 times 3, so 15 is my common denominator. What goes here? Well, that is that bit, so 2 times 3 is 6. What goes here? Well, that is that bit. So that's 2 times 5 is 10. Adding that together would give me 6 add 10 is 16 over 15. Now you should think to yourself now, that is top heavy. I can change this into a mixed, so that would be 1 over, because 15 goes into 16 one whole time with, remember, it'll always be over 15. How many left over? How do you get from 115, which is 15, to 16? There is 1 left over. And then finally on the last question, same thing. Cannot add these because there is not a common denominator. So we'll make one. 2 blank fractions ready because I know I'm going to change them. Using the same method, what goes on the bottom? Simply 4 times 3, which is 12. What goes on top? 1 times 3 is 3. What goes here? 2 times 4, which is 8. The answer to this one would be 3 add 8 is 11 over 12. Okay. So hopefully you managed to follow along or get those yourselves. Subtracting fractions, exactly the same. You use the same rule. It's the same. You need a common denominator. You just subtract at the end instead of adding. Can I subtract these? No, they do not have a common denominator. Making a common denominator, 2 blank fractions ready with a minus sign in between. We can use that same method. 5 times 3 is 15. And again, that is just, this method is just me illustrating how you should be thinking about what does 3 and 5 go into 15. What did I do to 5 to make it 15? I times it by 3, so I have to times the top by 3, which is 2 times 3, which is what this line is telling us. 2 times 3 is 6. What goes here? 1 times 5 is 5. Now you just take them away. Once you have the same denominator, you just take them away. 6 minus 5 is 1 over the original 15. You never take away or add the bottoms once they're the same. So have a go at the next one and pause the video. So we cannot take these away yet because we do not have a common denominator. 2 blank fractions ready. Same method we can use. Common denominator would be 3 times 5, which is 15. What goes here? Simply follow the line. 2 times 5 is 10. What goes here? 1 times 3 is 3. 10 take away 3 is 7 over 15. Can we simplify? No, 7 is prime. Very, very similar. You've got some questions to practice. Pause the video, have a go at them, and then I will go through them. So hopefully you've had a go at those and you had something that looked like this. Again, always checking. Do they have the same denominator? No. We're going to write out 2 blank fractions and we're going to make a common denominator. So you should have got 5 times 7 is 35. 2 times 7 is 14. 1 times 5 is 5. Taking 14 away from 5 away from 14 would give me 9 over 35. And always checking, can I simplify? Is it top heavy? Next one. Again, do they have a common denominator? No. I need to make one. I need to make sure it has a common denominator. So, good tip, 2 blank fractions. Write them out ready, because you know. You can use this method. 5 times 7 is 35. So that is my common denominator. What goes here? 1 times 5. 5. What goes here? 7 times 2. 14. Can we do 5 take away 14? Yes, but it's going to take us into a negative fraction. So negative numbers, 5 take away 14 is going to take us past 0 on the number line. If I start at 5 and I take away 14, it's going to take me down to negative 9 over 35. Okay. Next one. Again, note, doesn't have a common denominator. 2 blank fractions ready. 35 on the bottom, because when I times the denominators together, I get 35. What goes here? 2 times 7 is 14. What would go at the top right here? 5 times 2 is 10. Taking away 14 and 10, we're going to get 4 over 35. Similarly, on the next one, 3 and 5. No, it is not common. 2 blank fractions ready, because we need to make it common. We need a common denominator always. Using the same technique, you could do 3 times 5 is 15. What goes in the top left? Hopefully you got 10. Top right, 2 times 3 is 6. Taking those away would get you 4 over 15. And then finally, do they have a common denominator? No. We need to make one. 2 blank fractions ready. Common denominator, 3 and 4 would be 12. Top left, 2 times 4 is 8. Top right, 3 times 1 is 3. 8 take away 3 is 5 over 12. 5 is prime, so therefore it cannot be simplified. So hopefully you managed to have a good go at those. There are the answers. We'll now move on and look at exactly the same, but with mixed numbers. We spoke about mixed numbers in the previous lessons. You always want to change your mixed numbers into top heavies. You can do that without making the mixed numbers top heavy when adding. However, it's very dangerous for students to get into the habit of doing that, because then they think they can do it for all operations. So it's safer just to turn it into a improper top heavy fraction first, rather than trying to put whole numbers together, because it can get a little bit confusing when trying to apply that method to timesing and dividing, and students just get all confused. So whenever you see a mixed number, I want you to change it into a top heavy improper fraction. So by doing that, if we look at the first one, we're going to change both of these mixed numbers into top heavy fractions. Remember, 2 times 2 is 4, plus 1 is 5 over the original 2. Next one, 5 times 3 is 15. Add the 2 would be 17 over 5. Can we add these? No, we cannot. We do not have a common denominator, so now we need to make a common denominator. So again, get yourself 2 blank fractions ready. We can use that same technique, so it all builds upon each other. The common denominator is going to be 2 times 5 is 10. What goes here? 5 times 5 is 25. What goes here? 2 times 17 is 34. Adding together, 25 and 34. And again, if you're not confident doing it in your head, a really good exam skill would be to just do a column on the side. Don't feel like you have to do things in your head. You can just do a column, add them up if it's quicker for you, and makes things easier, that would be 59 over 10. You should now realise this is top heavy. Improper. Let's turn it back into a mixed. So as a mixed number, how many times does 10 go into 59 whole? It goes in 5 whole ones with 10 left over as my denominator. It always stays the same. How many are left over? Well, 5 whole ones would be 50. How many do I need to get to 59? 9. So the answer to this one is 5 and 9 tenths. Is exactly the same, and again, you want to get a clear method. I like to draw arrows down to show that I'm changing into top heavy, then do my common denominator, then work it out, and then change to a mixed. So get a nice clear system with your workings will make things a lot easier. It's exactly the same for subtracting. First thing you should say to yourself, right, mixed numbers need to be changed. Need to get them to be top heavy. Improper. 2 times 2 is 4, plus 1 is 5. Over 2, always over the original. Next one, 5 times 1 is 5, plus 2 is 7 over 5. Can we subtract these? No, we can't. We do not have a common denominator. Making a common denominator would be, again, we can use that method where we go from here to here to here to here and follow the lines. 5 times 2 is 10. What did you do to 2 to make it 10? You timesed it by 5, so that would be 5 times 5 is 25. 2 times 7 is 14. Now we have a common denominator. Now we can take away. 25 minus 14 would be 11 over the original 10. You don't change the denominator once it's the same. That is top heavy. What can we do to make it a mixed number? We can ask ourselves, how many 10s go into 11 whole? 1 whole one with 1/10 left over. And that is the final answer for that one. So that leaves you to have a go at those ones. So you can pause the video, see if you can replicate the method. I'll explain it. Then you've got plenty of fraction questions to have a go at. So hopefully you managed to have a go at these two here. And the first thing you should have done is realize these mixed numbers need to be changed into top heavy fractions. Again, write out 2 blank fractions ready. 3 times 2 is 6, plus the 1 on top is 7 over the original 3. We know this one will be 5 as the denominator. So we can say 5 times 3 is 15, plus 2 is 17. Can I add these? No. I do not have a common denominator, so I can write out 2 blank fractions ready. We need to make the denominator the same, so we can use our method. 5 times 3 is 15, so 15 will be our common denominator. What goes here? 7 times 5 is 35. What goes here? 3 times 17. Again, if you're unsure, you could do a column and just times it that way. It's going to be 51, but 3 times 7 is 21, carry the 2. 3 times 1 is 3, plus the 2 is 5. So we're going to get 51. Adding those together will give you 86 over 15, which is top heavy. So you need to ask yourself, how many times does 15 go into 86? Well, you can do your 15 times table down the side. 15, 30, 45, 60, 75, 90. 90 is too many, so that would be 1, 2, 3, 4, 5 whole ones. How would you get from 75 to 86? That would be 11 over 15 left over. And finally, Same thing. You should have realized these mixed numbers need to be changed to top-heavy fractions. 3 times 2 is 6, plus 1 is 7 over 3. 5 times 1 is 5, plus 2 is 7 over 5. Can I subtract these? No, I do not have a common denominator. So write yourself out 2 blank fractions ready, with a minus sign in between. What will our common denominator be? Hopefully you got 15. With 7 times 5 is 35 here. And 7 times 3 is 21 here. Now we can subtract these. 35 minus 21 would give you 14 over 15, which cannot be simplified, nor is it top heavy. So hopefully you managed to get those. You have to be organised and you have to know your rules. So it is worth now going through this worksheet that I've put at the end, which has a mix of all of the fraction stuff we've looked at. Timesing, dividing, adding, subtracting, mixed numbers, improper fractions, simplifying, cross-cancelling. Everything that you've learned or watched and followed along can be now tested and applied in all of these questions here. The biggest misconception students make is they get all of the rules in their head mixed up, and that is because they don't practice them enough. They understand how to do it when they learn it, then they just forget about it. They think, oh, I know how to do that. But the most important thing is you practice plenty of questions so you know which rule applies to which operation. You only need a common denominator when you add or subtract. When you times, you just times across or cross cancel. When you divide, you keep, change, flip. You need to be clear that these rules apply to the right fractions and the right operations, okay? So have a go at those. The answers to the worksheets here will be in the description. Hopefully you learned something there and managed to follow along, and I'll see you in the next one.